Dear students, very good morning and welcome to the lecture series session on EC402 Nanoelectronics. In the last class, we have discussed about the production of nanoparticles and some of the methods which can be used for the fabrication of nanoparticles. Today, we are going to discuss about the precipitation of quantum dots, or how quantum dots can be prepared using precipitation method. So what is meant by precipitation? Precipitation is a process of conversion of a chemical substance into a solid from a solution by converting the substance into an insoluble form, that is the solid form. So we have a solution of chemical substance in the liquid form, and that liquid is actually solidified as precipitate on the bottom of the container, that you might have learned in chemistry classes. The same kind of procedure is taken here also as precipitation. So precipitation is the process of conversion of chemical substance into a solid form by converting the substance into an insoluble form. Actually, from a solution, this conversion of the substance takes place in the insoluble form, that is the solid form. Now, quantum dots are actually the three-dimensional semiconductor materials, and which falls under the category of particles. And sometimes it is very difficult to differentiate the nano defects and quantum dots on the surface of the nanomaterial. The differentiation sometimes makes difficulty. Actually, the precipitation is the creation of a solid from a solution. When the reaction occurs in a liquid solution, the solid formed is called the precipitate. The chemical that actually causes to form this solid is called the precipitant, or actually the chemical that actually causes for the solidification of the precipitate at the bottom of the container, and that chemical which causes this particular solidification of the or precipitation is called precipitant. And precipitation is used in the manufacturing of cadmium sulfide, cadmium selenide, cadmium telluride, gallium arsenide, and silicon nanocrystallites in silica glasses. In the precipitation method, actually contaminants are added to the melt. Contaminants means what are all those solutions which have to be precipitated, and what is the material which has to be prevented, contaminants that are to be added to the melt. And this process takes place at high temperature. Following annealing process at a temperature of about 600 to 1400 degrees centigrade. Under this condition, they form precipitates of controllable size. Okay, so when annealing process is done at a temperature of 600 to 1400 degrees centigrade, in the precipitation process it takes place, and the controllable size of this quantum dots could be made, or actually that could be precipitated in the form of precipitates of controllable sizes. And again, the quantum dots can be manufactured using lithographic technique. How lithography can be used? What is meant by lithography? You might have heard in the microelectronics what is meant by lithography while you were learning the manufacture of chips, isn't it? The same thing. The lithography is a process of pattern formation. Electron beam lithography is a technique used for patterning integrated circuits and semiconductor devices with the use of an electron beam. And actually the equipment setup consists of a vacuum column with an electron source accelerating the electrons, magnetic lasers to control the electron acceleration and control the electron movement, and a steering system to control the flow of electrons or movement of electrons. And this electron beam lithographic system formation that produces the flux of electrons, actually that produces the flux of electrons accelerate to energies in the range of 20 to 100 kilo electron volt. So such a range of energy is produced with this acceleration of electrons, and that is actually focused into a spot, and that spot size is about 0.5 to 1.5 nanometer in diameter. Okay, and this procedure takes place mostly in such a way that the material which is to be converted to quantum dots is deposited upon a substrate like gallium arsenide via MBE. So if you want to produce quantum dots, first the material of the quantum dots, or the quantum dots, the material of which the quantum dots are to be produced is first deposited on the substrate like gallium arsenide. And how this can be done? This can be done with the help of molecular beam epitaxy or epitaxial method. The size of the electron beam spot actually determines the smallest possible size of the quantum dot produced. So with lithographic electron beam lithography, actually that can be used for the production of these quantum dots on the surface. And the size of this quantum dot produced is actually the electron beam spot that actually determines the size of the quantum dot, the smallest possible size of the quantum dot. And they are further reduced, and this size of the quantum dots I told you, that is the size of the electron beam possible, or what is the smallest possible electron beam that can be directed upon the surface. That is the smallest possible size of the quantum dot which can be produced. And they are further reduced by etching process, so that quantum dots of some 10 nanometers, sometimes few nanometers can be produced. And since we want to have a very high resolution for this process, electron beam lithography must be employed for producing quantum dots. Okay. Another method is the co-deposition of quantum dot with thin film. Of course, the quantum dots can be produced upon thin film surfaces. Common principle is the production of nanocrystallites in a separate step. Actually, first we will produce the nanocrystallites of the material, and that is done by the help of evaporation, laser ablation technique, or sputtering technique. First we will produce, the nanocrystallite of the material, and that is produced with the help of evaporation or laser ablation techniques or sputtering technique. Then what we do? Then they are directed towards a substrate, which is however covered at the same time with a film. Actually, they are actually directed towards a substrate, and that is covered with a film already. And so that when this particular substrate is directed, that particular see what we say, the laser ablation or whatever type of beam which that electron beam we are using, that is directed towards the substrate, isn't it? So that is which is covered at the same time with a film, so that they are included in this film. Actually, this particular quantum dots that are actually included into this film. Already there is a layer of film provided on this particular substrate, over which this particular new quantum dots are produced. Okay, so that is why it is called co-deposition. Already the films and nanofilms have been deposited upon the substrate over which these quantum dots are deposited, or the quantum dots are produced. Okay, so with this we conclude this session here as precipitation of quantum dots, and we just learned this quantum dot, and we just read my notebook and get the idea in a detailed way. Thank you very much for the patiently hearing my lecture session. Thank you.